Okay, I'm going to go over the worksheet or the review sheet for exam 1 in this lecture. So problem 1 says to find the area between y equals sine x and y equals cosine of x for 0 less than or equal to x is less than or equal to pi over 2. And so the graph looks like this. So here's sine x between 0 and pi over 2. And here's cosine x between 0 and pi over 2. So cosine of x, sine of x. Okay, so the area is going to be given by the integral. So they meet at x equals pi over 4. The area is the integral from 0 to pi over 4 of cosine of x minus sine of x. That's this region here, dx, plus the integral from pi over 4 to pi over 2 of sine of x minus cosine of x dx. And if we integrate, we get sine x plus cosine of x from 0 to pi over 4 plus the integral of negative sine x, negative cosine x minus sine x. In other words, let me write it like this, minus sine x plus cosine of x from pi over 4 to pi over 2. If you do the evaluation, I'll spare you the details. You're going to get twice the square root of 2 minus 2. So that is problem 1. So in problem 2, we're supposed to find the volume generated by rotating around the y-axis. The region bounded by y equals ln of x for 1 less than or equal to x less than or equal to e. Now, someone pointed out, this is 1 to e, so someone pointed out legitimately that this is not a well-founded problem, because what do we mean by the bounded region? Well, let's just say it's this region here. So it's 1 less than or equal to x less than or equal to e, and we want y to be between 0 and ln of x. This is what I mean. Okay, so if we rotate this region around the y-axis, we're going to rotate it that way. We are going to get this little strip here of thickness delta y. It's going to generate a washer. And we have a big radius, and we have a smaller radius. So the volume generated by this little thick washer of thickness delta y, the volume of the washer is approximately given by pi times big R squared minus pi times little r squared times delta y. And big R is given by e, so it's pi e squared minus pi times little r squared. Little r is the distance from the curve to the y-axis. So we want to write that in terms of y. So y is ln of x, so x is e to the y. So we're going to get pi e to the y quantity squared. This is all multiplied by delta y. So we want to get the volume in question. It's going to be the integral. Okay, so what is y going from? Y is going from 0 to ln of e, which is 1, 0 to 1, pi times e squared minus pi e to the y squared, which is pi e to the 2y. So if we factor out a pi, we get e squared times y minus Okay, the antiderivative of e to the 2y is 1/2 e to the 2y. This is from 0 to 1. Okay, and if we evaluate this, we get pi. So if we stick in 1, we get e squared minus 1/2 e squared. And if we stick in 0, we get 0 minus 1/2. So this ends up being, if I got this right, pi over 2 e squared plus 1. So that's that problem. So problem 3 is the integral of x times the square root of x plus 1 dx. Now, I pointed out you can do it either by integration by parts or substitution. I'm going to do it by substitution. I'm going to let u equal x plus 1, then du is dx. So this integral is, well, what is x? X is equal to u minus 1 times the square root of u times du, which is u to the 3/2 minus u to the 1/2 plus c, which is x plus 1 to the 3/2 minus x plus 1 to the 1/2 plus c. So that's the answer. Okay, so we now come to problem number 4, which is a work problem, and we're going to use the fact that 2 inches is 1/6 of a foot. We have to use everything in terms of feet, not inches, because work in the English system is always expressed in terms of foot-pounds. So a force of 5 pounds is required to hold the string stretched 2 inches beyond its natural length. So if we let f of x equal kx by Hooke's law, that tells me f of um, f of f of 1/6 is k times 1/6, and that's going to be given by 5 pounds, because F is the force, so that says that K is equal to 30. And so the question is, how much work is done in stretching it from its natural length to 3 inches beyond its natural length? So that's going to be the integral from 0. Now, what is 3 inches? That's 1/4 of a foot of kx dx, which is 30x dx. So we get 15x squared is the antiderivative from 0 to 1/4. And we get 15th, 16th foot-pounds. Okay, so that wasn't so bad. Okay, so now we come to the integral from minus pi over 2 to pi over 2 of sine 7th x dx. And this is a trick question. It's an odd function, and what does an odd function do? An odd function has the property that whatever it does to the right of the y-axis, it does the mirror image with respect to the x-axis. So if we're integrating from minus a to a, an odd function, dx, we're always going to get 0. So this is sine 7th of x is an odd function, so we better get 0. Nothing to it. Now we come to problem number 6, which is an average value question. And 6 hours, so 6 a.m. is the start time and 6 p.m. is the end time. And so we're trying to take the average temperature. So it's the integral from 0 to 12 of ln of t plus 1 dt, and it's 1/12 is in front of it. That's the average value. So f average, t average is this. So I'm going to let u equal t plus 1, so du is equal to dt, and this becomes 1/12, the integral. Now when t is 0, u is 0 plus 1, so the bottom limit of integration is 1. And when t is 12, u is 13. So it's ln of u du. And now you can do this by parts, but you could also remember we did this in class, and we'll get u ln of u. If you do this by parts, u ln of u minus u was the answer from 1 to 13, and that's 1/12. So if we evaluate it at 13, you get 13 ln of 13 minus 13 minus 0, ln of 1 is 0, minus 1. And so this becomes, if you do some arithmetic, this is 13/12 ln of 13 minus 1. So that's the answer to that question. Okay, so now we come to problem 7, which is the integral of dx over x times the square root of x squared plus 1. This is one of those trig substitutions. I'm going to let x equal tangent theta. Dx is secant squared theta d theta. And what do you get? Well, you're going to get the integral of secant squared theta d theta on top. The x is tangent theta, so that goes there. And then the square root of 1 plus x squared is the square root of 1 plus tangent squared theta. So that's the square root of secant squared theta, which gives me a secant theta after I do the reduction. And this becomes the integral of secant theta. There's a cancellation of the secant theta on top on the bottom. And if you turn this to sines and cosines, this becomes the integral of 1 over sine theta d theta, which is the integral of cosecant theta d theta. Now, I did this in class. The integral of cosecant theta is minus ln absolute value of cosecant theta plus cotangent theta plus c. So now we have to go back and convert this back into x. So now if x is tangent theta, that means if we let x be the opposite and then the adjacent would be 1, then the hypotenuse is 1 plus x squared. So now this minus ln, what is cosecant theta? That's the 1 over sine, and so therefore it's hypotenuse over opposite. So it's this ln, the square root of 1 plus x squared over x, plus the cotangent, which is the adjacent over opposite, plus c. So that is where we are. We're done with this problem. So I'm going to save problem 8 to the end because that is the hardest and longest problem. So let me go directly to problem 9. And we want to integrate ln of x dx over x to the 5th. So I'm going to use integration by parts. I'm going to let u equal ln of x, du is dx over x, dv is dx over x to the 5th, or in other words, x to the minus 5th dx. So v is, what is v? V should be x to the minus 6th. Nope, that's not right. What is it? V will be minus a quarter x to the minus 4. If you take its derivative, you see you get x to the minus 5th. And so what does the integral become? Becomes uv, which is minus a quarter x to the minus 4, ln of x, minus, but there's going to be another minus sign making a plus, the integral of dx. So x to the minus 4th divided by x is x to the minus 5th, so it's minus a quarter, that's a quarter, dx over x to the 5th. Okay, so, and then this becomes minus a quarter, x to the minus 4th, ln of x, plus a quarter, times the antiderivative of x to the minus 5th, which we just did as minus a quarter, x to the minus 4th, plus c, and then we should simplify this as minus a quarter, x to the minus 4, ln of x, minus a 16th, x to the minus 4th, plus c. So now we come to the painful problem of x plus 1 dx over 9x squared plus 6x plus 5. You can check the denominator is not a reducible polynomial. The discriminant in the quadratic formula is negative, so it does not have real roots. So here's my proposal. Let's first of all complete the square. So 9x squared plus 6x plus 5 is given by 9 times the quantity x squared plus 2/3 x plus 5/9. And if you think about what that is, that's 9 times x squared plus 2/3 x. I'm completing the square, so I could put 1/9 here, and the remaining stuff is 4/9. So this becomes 9 times x plus 1/3 quantity squared plus 4/9, which I can think of, if I like, as 9 times x, oops, let me do it this way, 9 times x plus 1/3 squared plus 4. Okay, why did I do that? Well, I'm going to let u be equal to x plus 1/3. Then du is dx. And if I do that, then I get the integral becomes, well, x plus 1, but that's u, x plus 1/3 is u, so this would be u plus 2/3 is x plus 1 times dx over 9u squared plus 4. So that's my first reduction. And I'm going to rewrite this integral as the integral of, oops, there should be a du, sorry. I'm going to break it up into two fractions. The integral of u du over 9u squared plus 4, which is easy to do. And then another one which is not so easy to do, which is 2/3 du over 9u squared plus 4. And the thing we have to remember is everywhere is that x is u plus 1/3. Okay, so x is u plus 1/3. Okay, I'm sorry, u is x plus 1/3. So u is x plus 1/3. Let me write that up here because I'm going to need some additional space. Okay, so let's call this integral 1 and this integral 2. I'm going to handle 1 first. That's the easier one. So if I let v be, I'm going to do this by substitution. V is 9u squared plus 4. So dv is equal to 18u du. So 1/18 dv is u du, which is what we have in the integrand. So 1 is equal to the integral of 1/18 dv over v. So that's 1/18 ln absolute value of v plus c. So that's 1/18 ln. Now 9u squared plus 4 is always non-negative, so I don't even need an absolute value symbol of 9u squared plus 4 plus c. Okay? So in fact, we can rewrite this if we want as 1/18 ln. 9u squared plus 4 was what we got when we converted the denominator of the original integrand into the u variable. So this would be ln of 9x squared plus 6x plus 5 plus c. Okay, so that's 1. So now we come to the second integral, which is the, if you go back, 2/3 du over 9u squared plus 4. I'm going to rewrite this in a slightly different fashion. I'm going to first of all bring the constant out, and then you have du over 3u quantity squared plus 2 squared. I'm going to think of it that way, and that suggests a trig substitution. I'm going to let 3u equal 2 tangent of theta. If I do that, then 3 du equals 2 secant squared theta d theta. In other words, du is equal to 2/3 secant squared theta d theta. And this becomes 2/3 the integral of 2/3 secant squared theta. And now what's on the bottom? Well, if we take 3u squared plus 2 squared, or 3u squared plus 4, that's going to be given by, is going to be given by 4 secant squared theta by the trig identity. So this is going to be 4 secant squared theta. And there's a d theta here, of course. Okay, so then if we take the constants out, we get a 1/9, and then we got the integral of d theta. So this is 1/9 theta plus c. Now what is theta? Well, we can solve for theta. 3/2 u is tangent theta. So theta is the arctangent of 3/2 of u. And we can go even back to x because we get the arctangent of 3/2 of x plus 1/3 plus c. And so I'll go back and write this as 1/9 arctangent of 3x. I'm going to distribute the 3/2 through. So 3/2, 3x plus 1 over 2, it is, plus c. Okay, so now the final answer to this problem is what you get by summing up 1 plus 2. And what do you get? Well, you should get, if I did this correctly, what do we get? We get what I erased on the previous slide, 1/18 ln of 9x squared plus 6x plus 5 plus 1/9 arctangent 3x plus 1 over 2 plus c. That's the final answer to this problem. And it's also the last problem that we have to do on the worksheet. So there you have it. That's the worksheet. Prepare, and you'll do well on the exam.